Good morning everyone. I welcome you all for the course Concrete Technology. Today we are going to see about cement and hydration of cement in this video. First one is cement. Cement is a binder material which set and harden and can combine the other materials together. The principal constitution of the cement are calcareous and aggregates compounds. The chemical composition of the cement consists of lime, silica, alumina, iron, magnesium oxide and gypsum. Lime, silica and alumina are responsible for the strengthening of the cement, whereas the iron oxide are responsible for the color of the cement. Gypsum helps in the preventing the setting of cement. Cement are usually classified as hydraulic and non-hydraulic cement. There is cement having a property of setting and hardening under water by chemical reaction. They are called as hydraulic cement. The classification of cement based on the occurrence. The cements are classified as natural cement, pozzolanic cement, slag cement and then Portland cement. It is a variety of an artificial element. It is called Portland cement because on hardening its color resembles the rock near the England, which is Portland. Portland cement. The Portland cement are formed by the proper and proportionate mixing of the aggregates and calcareous raw material, and then heated. They are burned at a temperature of about 1500 degrees Celsius. Then they are extremely grounded by calcination together. This is an image of the Portland cement. The Portland cement mainly consists of the bogey compounds. They are called as clingers. They are tricalcium silicate, dicalcium silicate, tricalcium aluminate and tetracalcium aluminoferrates. Previously we have seen the chemical constitution of the cement. At the temperature of the 1500 degrees Celsius, these chemical compounds combined form the clinger compounds. The next one is raw materials used for the cement and their uses. First one is calcareous material, which consists of lime. It is then principal constitution and its proportion should be regulated because the excess of the lime reduces the strength and makes the cement expand and disintegrates, that is unsound, whereas less amount of lime also reduces the strength by quick setting. So an optimum amount of the calcareous material is maintaining should be important. The next one is argillaceous materials. It consists of alumina and silica. Example clay. It imparts strength and makes quick setting. The excess of the alumina also weakens the cement. The next one is powder coal and fuel oils, which is used for burning purposes. Then gypsum, which is used for repair and enhance the quick setting. Properties of cement, that is setting and hardening. When the water mixed with cement, the hydration and hydrolysis reaction of the bogey compounds begins, which result in the formation of gels and calcinated crystal products. These products has an ability to surround the materials like sand, bricks and crushed stones. Setting is nothing but the stiffening of the original paste masses due to the formation of the turbomonoid gel. Usually it can be divided as a two process, initial setting and then final setting. That is, initial setting is that when the paste begins to stiffen, that is hardening, solidification of the paste. Whereas The final process is the final set is that when the paste begins to harden, that is after the harden, after the stiffening purpose, the paste begin to harden, that is it can able to take some loads. Hardening is an development of state due to formation of the crystals. Unhydrated cement, when that is before adding water to the cement, the cement doesn't have any binding properties. After addition of water, the hydration takes place. The hydration results in the formation of the crystalline hydration products and then metastable gels. These metastable gels on course of time will form a stable gel and then they form some crystalline products. The next one is sequence of changes occur during setting and hardening of cement. First one is when the cement is mixed with water, it forms a paste. During first day, the hydration of the tricalcium aluminate and tetracalcium aluminoferrate takes place. On the 7th day, the gelation of the tricalcium silicate takes place. On the 28 days, then gelation of the dicalcium silicate and tricalcium aluminate takes place. We can see the detail in the upcoming slides. During first day, when the water is added to the cement, the hydration of the tricalcium aluminate takes place within a day. The paste became rigid, which is also known as initial set or flash set. So, the initial set or flash set is due to the hydration of the tricalcium aluminate. The tricalcium aluminate on reaction with water form a hydrated tricalcium aluminate crystalline form with a release of 880 kilojoules per kg. Usually, hydration process is an exothermic reaction which results in the liberation of the heat. To avoid an early setting of the tricalcium aluminate, gypsum is added to the cement which acts as a retarding agent. Tricalcium aluminate on reaction with gypsum, it forms a calcium sulfoaluminate. It is important to reduce the reaction of the tricalcium aluminate in the initial stages because it results in large amount of heat evolution which are responsible for the formation of the hairline cracks in the concrete. Next, the reactions during 2nd to 7th day. After the hydration of the tricalcium aluminate, tricalcium silicate begins to hydrate. It will form an turbomonate gel and then crystalline calcium oxide, which is responsible for the initial strength of the cement. Hydration of the tricalcium silicate completed within 7th day. The chemical reaction, that is tricalcium silicate on reaction with water form turbomonate gel plus crystalline calcium hydroxide. This turbomonate gel is also known as CSH gel. This reaction results in the liberation of 500 kg joules per. The turbomonate gel possesses very high surface area as well as very high adhesive properties. So it is responsible for binding all materials in the concrete. Also, due to its high surface area, it will occupy more volume which result in the filling of pores in the concrete. Next one, reaction during 7 to 28 days. After 7th day, the dicalcium silicates started to react with water slowly, and then it will complete it in 28 days. A dicalcium silicate react with water, form CHS, same CHS gel and crystalline calcium hydroxide. Whereas when compared with the gels formed due to the tricalcium silicate, dicalcium silicate gels are superior in nature and then in properties. It will liberate in less amount of heat when compared to tricalcium silicate and then tricalcium aluminate, 250 joules per kg. Increase in strength is due to formation of the turbomono gel, that is CHS gel, and crystalline calcium hydroxide. Next one. After the initial hydration of the tetra calcium aluminoferrate, the hardening takes place to crystallization along with C2S. That is, tetra calcium aluminoferrate react with water, forms the crystalline calcium aluminate plus gels. The hydration and the hydrolysis of the bogey compound causes the cement to develop the compressive stress. Here we can see from this chart, that is the initial strength of the cement is due to the hydration of the C3S, that is tricalcium silicate, and then due to dicalcium silicate there has been a slow and steady increase in the strength of the concrete. The tricalcium aluminate and tetracalcium aluminoferrate are just responsible for the stiffening purposes. Here we can see that the setting is due to the tricalcium aluminate and tetracalcium aluminoferrate, whereas hardening is due to the tricalcium silicate and then dicalcium silicates. Functions of gypsum in cement. The tricalcium aluminate react with water. A rapid amount of heat is released. Okay. After the initial state, the place became stiffened. During stiffening, when the large amount of heat is or releases, they result in formation of the hyaline cracks. Okay. So adding the gypsum will retard the dissolution reaction of the tricalcium aluminate by formation of the insoluble calcium sulfoaluminate. It will retard the initial setting of the cement. Heat of hydration of cement. When cement is mixed with water, hydration and hydrolysis takes place. It will result in the liberation of heat. It is known as heat of hydration of cement. An average of 500 kg joules per kg of heat is liberated during the complete hydration reaction of the cement. The bogey compounds tricalcium aluminate and tricalcium silicate are account for the large amount of heat liberation, whereas the tricalcium silicate result in less amount of heat liberation when compared with the other bogey compounds. The next one is special cements. White cement. White cement is white in color, which is due to the absence of the iron compounds. By calcinating the raw materials of the Portland cement, which is free of iron oxide, result in the white cement. Usually, the white cement is more expensive than the ordinary Portland cement. It acts as an pore blocking as well as water repelling agents. Hence, they are used in the repairing and joining of the pillars and other blocks. They are also used in the manufacturing of tiles and mosaic walls. The next one is waterproof cement or hydrophobic cement. They are formed by adding certain water proofing substance like calcium stearate, aluminum stearate, gypsum with tannic acid to the ordinary Portland cement. They are also act as a pore blocking and water repelling agent. They are used for making concrete which is impermeable to water even underwater. They are used to make concrete which is impermeable to water under pressure. And they are also used in the construction where the absorption of water should be avoided. They are used in the construction of bridges and underwater structures.